In this lesson, you will learn how to solve a quadratic equation using bottoms up. Let's go ahead and take a look at the first example. In this first example, we have a quadratic equation, 2x squared minus 17x equals negative 8. The first thing you want to do is you want to rearrange the equation and put it in standard form, which means all the terms should be on the left side of the equal sign. So to do this, we need to simply add the negative 8 to the other side. So if we add it to the right, it will cancel it from the right and move it over to the left, giving us 2x squared minus 17x plus 8 equals 0. Now we can go ahead and solve this. Now recall from previous lessons, when you solve a quadratic equation, what you are finding are the x-intercepts of the graph. Now, if you remember the process of bottoms up, you use this when the number in front of x squared is greater than 1. So in bottoms up, you start by circling the a and the c term. We're going to draw a little arc between them, reminding us that we're going to be multiplying the 2 and the 8 together in just a moment. Then I will underline the x squared and the negative 17x. We're going to go ahead and drop that down. Then I will multiply the 2 and that 8 together and make that the c of my new quadratic equation. Now the reason why I do this is I want to create a trinomial whose leading coefficient is 1, which means the number in front of the x squared is 1. By doing this, I should then hopefully be able to use the double bubble method to factor the next part. So now I'm going to go ahead and factor this. And to do this, I'm going to find all of the factors of 16 that have a sum of the middle term, negative 17. So let me start by listing the factors of 16. Now because the coefficient of x in the middle, the negative 17, is negative, when I list the factors of 16, I need to use negatives. So how can I get a positive 16 using negatives? Well, I can multiply negative 1 and negative 16, negative 2 and negative 8, and negative 4 and negative 4. So now I have to choose the two that have a sum of the middle term, negative 17. And if you look at your three choices, the first choice, negative 1, negative 16, if you add them together, you get negative 17. So if you go back up to the parentheses, you're going to split the x squared up and put an x in each parenthesis. Then you're going to put a negative 1 in one of those parentheses coming from your two factors, and a negative 16 in the other. However, you are not done, because what you've done so far is simply factored the trinomial with the coefficient of 1, but what you need is to have the answer that would get you back to your original trinomial. So at this point, you're going to bring that 2 down, which is your a in your quadratic equation, and you're going to actually stick it underneath both the negative 1 and the negative 16. So it goes on the bottom of those numbers. And this is how the phrase was termed bottoms up. Now, if you look at the 1/2 in the first parenthesis, if you cannot reduce that fraction or divide it, then the bottom number will come up in front of the x. That's why it's called bottoms up. So we really have 2x minus 1. In the second parenthesis, because we can divide the negative 16 in 2, we're going to go ahead and divide that, and we don't have to do bottoms up on that particular binomial. So it will just be x minus 8, then equals 0. So once you've factored this, and you're confident that if you were to FOIL 2x minus 1 times x minus 8 and get back to your original trinomial, then you can go ahead and finish solving from there. So to finish solving, like in previous lessons, you want to draw a line between the parentheses. You're going to set each binomial equal to 0, creating two equations. From here, you're going to solve the two equations. When you solve the first equation, one of your x-intercepts or solutions is going to be 1/2. When you solve the second equation, your second x-intercept is going to be positive 8. So those would be your two solutions for this particular quadratic equation. Now, if you're familiar with the quadratic formula, you can actually double check your work using the quadratic formula. The quadratic formula can be used to solve any quadratic equation instead of using bottoms up, double bubble, or any other process you've learned. So we're going to go ahead and just use the quadratic formula to verify that our two x-intercepts are in fact 1/2 and 8. So just to remind you, the quadratic formula is x equals, x meaning the x-intercepts, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, what we do is we're going to plug in values for the a, the b, and the c. So just to remind you, in order to do that, we want to first again move that negative 8 over to the left so we have our quadratic equation in standard form. So the a is 2, the b is negative 17, and the c is 8. Now we're going to go ahead and plug in the values into the quadratic formula. So to start with the numerator, it says negative b, so negative 17, because b is negative 17, plus or minus the square root of b squared, which would be negative 17 squared, minus 4 times a, which is 2, times c, which is 8, all over 2 times a. From here, we're going to simplify each part of the quadratic formula. First, we're going to go ahead and change the double negative to a positive. So we would have x equals 17 plus or minus. Then we're going to square the negative 17, and negative 17 times negative 17 is positive 289. From there, we're going to multiply the next three numbers, negative 4 times 2 times 8, which would be negative 64. Then in the denominator, we will multiply 2 times 2, which gives us 4. From here, we're going to finish simplifying underneath the radical. So 289 minus 64 is 225. Now 225 is a perfect square, so we're going to go ahead and take the square root of 225, and we're going to make it equal to 15. So now we have 17 plus or minus 15 divided by 4. This is a point where you split them up, and you're going to use that plus or minus sign once. So you'll use the plus the first time, so 17 plus 15, and then divided by 4. And for the second answer, you'll use the minus, so 17 minus 15 divided by 4. And this will give you your two x-intercepts. So 17 plus 15 is 32, and 32 divided by 4 equals 8. And if you look back at the left side of the screen, one of our x-intercepts was in fact 8. 17 minus 15 is 2, and 2/4 reduces to 1/2. And again, if you look back to the left side of the screen, you will see that one of the x-intercepts was also 1/2. So that verifies that we did the problem correctly. So again, the quadratic formula can be used to find the x-intercepts of any quadratic equation and can be used instead of any other method that you've learned. But let's continue to focus on bottoms up. So let's look at an additional example. Okay, in this example, we're going to solve 6x squared minus 7x minus 3 using bottoms up. So because it's in standard form, we can just go ahead and begin. So we're going to circle A and C and connect them and eventually multiply them. First, we will drop down the x squared minus 7x as we begin the process of creating a trinomial with a leading coefficient of 1. We will now multiply the 6 and the negative 3 to get negative 18. From here, we will double bubble our new trinomial. So we need to figure out factors of negative 18 that have a sum of negative 7. So we're going to start by listing our factors of negative 18. Now, because 18 is negative, when you write down the different numbers that have a product of negative 18, one of those numbers needs to be negative. Now, you need to write down all options. So we have negative 1 and 18, and 1 and negative 18. Negative 2 and 9, and 2 and negative 9. Negative 3 and 6, and 3 and negative 6. So now what you'll do is you'll choose the pair that has the sum of that middle term, negative 7. And if you look at all your options, 2 plus negative 9 is negative 7. So those will be the factors we use in our parentheses. So we will put a positive 2 in one and a negative 9 in the other. And it does not matter what order you put them in. Now remember, at this point we're not done. We need to drop down the a, or the leading coefficient, which is 6, and put them on the bottom or underneath each of the numbers in parentheses. Now, 2 over 6 and negative 9 over 6 can both be reduced. So the first thing you'll want to do is reduce those fractions. So 2 over 6 reduces to 1/3. Negative 9 over 6 reduces to 3/2. Now, because the numbers are both fractions and they cannot be reduced any further, the bottom number will go up in both cases in front of the x. So you will have 3x plus 1 and then 2x minus 3. Now again, at this point before you finish solving, you may or may not want to FOIL this just to make sure that when you FOIL it, you get back to your original trinomial. And I can tell you right now that it does work in this case, so we're on the right track. So now we will create our two equations and solve both of them to find our x-intercepts. So when we solve the first one, our first x-intercept will be negative 1/3. When we solve the second one, our second x-intercept is 3/2, or 1.5. And again, you could choose to go back and use the quadratic formula, and you will get the same two answers using that method as well. Let's take a look at an additional example. Here it says, the area of a rectangle is represented by 3x squared equals 5x minus 2 units squared. If the width is represented by x plus 2 units, what is the length? And then part B says, if x equals 3, find the actual length, width, and area of the rectangle. So if we know that the area of a rectangle can be found by multiplying the length times the width, and we know the area is 3x squared plus 5x minus 2 units. Then if we were to factor that, we could find the factors of it, one which would be the length and one would be the width. Now what we know already is we know from the information given to us in A that the width is x plus 2. So we know this part of it. We just need to find the length. So in order to do that, we need to go ahead and do bottoms up on the quadratic equation, and that will give us the other half of the answer. So let me go ahead and erase this so I have a little bit of room. So we have 3x squared plus 5x minus 2. So we're going to circle the 3 and the negative 2. Then we're going to drop down x squared plus 5x. We'll multiply the 3 and negative 2 and get negative 6. From here, we will double bubble the x squared plus 5x minus 6. So we need to figure out what factors of negative 6 have a sum of positive 5. So over to the side, we will list the factors of -6. We have -1 and 6, and 1 and -6. -2 and 3, and 2 and -3. And the only option that has a sum of +5 is the first one, -1 and +6. From here, we will drop down the leading coefficient, which is 3, and put it on the bottom or under each of the numbers in parentheses. The 1 over 3 cannot be reduced, so we're going to do bottoms up on that. So we get 3x minus 1. In the second one, we can divide the 6 and 3, giving us x plus 2. Now we can stop here in this problem, and we can see that we've found the other half. The x plus 2 was given, but the 3x minus 1 was not. So the 3x minus 1 represents the length of the rectangle. Now that we know the expression that represents both the length and width and area, we can go to step B. So it says if x equals 3, we want to find the actual length, width, and area of the rectangle. So we're going to write down the expression for the length, but then since we know that x is 3, we're going to replace the x with 3, then calculate the actual value of the length. So 9 minus 1 gives us 8. For the width, the expression is x plus 2, and if we substitute in for x, the 3, the actual length is 5 units. So there's two ways to find the area. The long way would be to take your original quadratic and plug in 3 for both x's, so it would look like this. 3 times 3 squared plus 5 times 3 minus 2. So this is the long way. So when you calculate 3 squared, you get 9. Multiply that by 3 and you get 27. Add 5 times 3 or 15 to that and then subtract 2. So 27 plus 15 is 42. And 42 minus 2 would be 40 units squared for the area. Now, the quicker way to do it, since area equals length times width, now that we know the length and width, we just multiply the actual values together, and we would also get 40, much quicker. Here's an additional problem. The football is kicked into the air with an initial velocity of 43 inches per second from an initial height of 15 inches. So let me underline those. So the velocity is 43 inches per second, and the height is 15 inches. It says write an equation that models the height of the football in inches with respect to the time in seconds. And it gives you a formula to use. So we're going to plug in the 43 for the velocity and the 15 for the height, the initial height. Initial height is indicated by h sub o. Then v is the velocity. So we would have h equals negative 16t squared plus, and for the v we're going to replace it with 43, plus h sub 0, which is the initial height of 15. So we now have a quadratic equation. In part B, it says, after how many seconds will the football hit the ground? So we have to look and see what would we do to figure this out. So we're looking for time. So to figure out time or to solve for t, think of these like as if they were x's. If these were x's, and then we solved this using bottoms up, we would know our x-intercepts. Well, now these are t's, so now they're representing time. So if we solve these, we can figure out what t equals, which would be the time. And let's ignore this width and area at the bottom. Okay, so let's go ahead and write down our quadratic equation. We're going to set this equal to 0. And then we're going to go ahead and factor it and solve it using bottoms up. So let's circle the negative 16 and the 15. And let's drop down the t squared plus 43t. At this point, we need to multiply 16 times 15, which is 240. And it would be negative 240 because the 16 is negative. So we then want to factor this. So again, we need to figure out what factors of negative 240 have a sum of positive 43. Now I could list all of the factors of negative 240, but that would take me quite a while. The best thing to do is just go through one by one, and once you do that, you will eventually find that you'll be using negative 5 and 48, because negative 5 times 48 equals negative 240, but if you add those together, its sum is positive 43. So we're going to put a negative 5 in one parenthesis and a positive 48 in the other. We're then going to drop down the negative 16, and we're going to go ahead and simplify these. So this would give us, if we do bottoms up on the first one, negative 16t minus 5. And in the second one, you can divide 48 and negative 16, and you'll get t minus 3. So from here, we're going to create two equations and then solve them both. So we have negative 16t minus 5 equals 0. And if we solve this one, we will get negative 5 over, excuse me, negative 5/16. So let me go ahead right now and box that. We'll talk about that in a second. Then we have t minus 3 equals 0. And if we solve that, t equals 3. Now, in these real-life application problems, you need to actually look at the answer. Don't just assume what you get is in fact the answer. We have two possibilities for the time. So you got to look at it back and say, what's realistic? So the football is kicked into the air with a velocity of 43 inches per second from a height of 15 inches. And we want to know how many seconds will the football hit the ground? Now, which one is unrealistic? Because you will have an unrealistic answer with these, and that one you will ignore for this particular problem. So this is the one we want to focus on, t equals 3, which means that the football will hit the ground after 3 seconds. So the one that is negative, the value that's negative, will be the one that you ignore, because obviously time cannot be negative. And that completes the lesson on solving a quadratic equation using the bottoms-up method.